Okay, so this brings us to the second fundamental theorem of calculus. So what this says is if you have a continuous function and it contains this point A, then for every x in the interval, if you take the derivative of the antiderivative of the function, that gives you f of x. Now, let me simplify that. Let's ignore this for a minute. I'll show you exactly what's happening here. So we want to take the derivative, which we'll get to that in a minute, of the antiderivative of this function. Now, we don't know what the antiderivative of f of t is because we don't know what f of t is. So I'm just going to call it capital F of t. That's the antiderivative. And we're going to evaluate from x to a. Okay, so when we do that, we plug in x and we plug in a. Now, we want to turn around and take the derivative of that. Well, the derivative of f of x is just little f of x. And then remember, f of a is a constant because we're plugging in a number into this function. So that's a constant. When you take the derivative of a constant, you just get 0. So we don't have to worry about that at all. Okay, so this whole thing, going through this whole process, gives us f of x, which is exactly what this said before I scribbled it out. So essentially what's happening is we're changing our variable. Okay, so remember we started with a function in terms of t. We took the antiderivative and plugged in x, we plugged in a, and then we took the derivative of it. Well, that canceled out, and so then we now have a function in x. So that's our answer. We've just changed variables. Okay, this is actually a pretty simple concept. I don't know, sounds confusing maybe? I'm not sure. So here's what happens. We want to take the derivative of this antiderivative. So we want the antiderivative of this, which we actually don't know how to do. So I'm just going to call it big F of t, whatever it is. And we're going to evaluate that from x to 0. Then we plug in x, and we plug in 0. And then we're going to turn around and take the derivative of that whole thing. F of 0, that's a constant, so we don't need that part because the derivative is just 0. So our derivative is just what we started with, except now we are in terms of x. So our final answer is going to be the square root of x squared plus 1. Okay. Now, one thing, so actually we didn't need any of this work, okay? We can just go straight to this. Now, one thing that I should note, and that was not included in this definition up here, is that you may need to include a d of x. It should be f of x dx. Because if you have something up here more complicated than just an x, we have to include it. We have to take the derivative of it. And that happens in our next problem, so I'll show you. Okay, so in the next one, we want to find the derivative of this. So we want to take the derivative of this thing in terms of x. So we want to take the antiderivative of cosine, but then we're going to turn around and take the derivative again. So our answer is going to be just cosine again, okay? Because we take the antiderivative and then take the derivative, we should get back where we started. But instead of t, we are going to be in terms of x. So it'll be cosine x cubed. Remember, when we plug this thing in and then take the derivative, that's going to be a constant. It'll cancel out. We don't need that. Now, what we do need to do is multiply by the derivative of this thing. Okay, so our answer is going to be cosine x cubed times 3x squared. Okay, but in general, if our function had just been from pi over 2 to x of cosine t dt, we wouldn't have had to worry about that. We would just said, hey, look, I'm taking the antiderivative and then I'm taking the derivative. I'm just changing my variable. So this is going to be cosine of x. And then the derivative of that is just 1. So that's why we didn't have to worry about it before. We have one more problem to do in our last video, and it's putting a bunch of these ideas all together.